Okay, so way back in chapter 4, part 2, we talked about how to find the period of a trig function. Okay, and so to find the period of a trig function, we need to know that sine and cosine, their typical period is 2 pi. If there's any type of b transformation that's going to impact the period, and to find the period, you're going to do 2 pi times the reciprocal of b, so 1 over b. What we want to think about is what's going on between sine and cosine in terms of how many answers they have. So, and answers would be where it touches the x-axis. So right now it looks like on the interval, and this would be 0 to 2 pi on all of them, it's hitting 3 times. When I have sine of 3x, so this is going to be a new period of 2 pi over 3. We have 1, 2, 3, 4, 5, 6, 7 different places that it hits. 1, 2, 3, 4, 5, 6, 7. And then you compare the two, and these are just the last picture is just a picture of sine of x and sine of 3x. You can see the period is compressed on 3x, and there's a lot more answers. That's kind of the main focus. There's a lot more answers that are going on. Same for cosine. So if I'm looking at the same 0 to 2 pi, we got 1, 2, 2 places. This is cosine of 4x, so the new period would be 2 pi over 4, which would be pi over 2, so that's the new period for that guy. And we can see we got 1, 2, 3, 4, 5, 6, 7, 8. 8 little places that guy comes in, and we have an answer. And there's those two kind of comparing that. So the idea is that when I change the period of the function, or I have a b transformation, I'm going to change how many answers I have as well, because the answers are really like the zeros or the roots or the x-intercepts of these graphs, of these equations, of these functions. So if I start messing with the period, I'm changing how many times it repeats in that time in that interval. If I change the period, I'm going to change how many answers I get. That's going to be the next type of equation that we're going to work with. So when we change the period of a trig function, we alter how many answers we need to find on that interval. We're always going to be on the 0 to 2 pi interval. Steps are relatively the same, okay? So we're going to start by solving the trig function just like we did, but when the angle has a coefficient, when the angle has a b, you have to look up that many rotations worth of answers. So if we were solving cosine of 3x, we would need to look around or go around the unit circle 3 times to find all of the answers. Just like maybe if we change that to sine of 7x, then we would go around the unit circle 7 times. Once we have all of those answers, we're going to take all of those answers and multiply them by the reciprocal of b, so 1 over whatever that b is. All of our final answers are going to be within that one rotation or less than 2 pi. So they're all going to still be smaller than 2 pi. That's what we're kind of looking for. And if we go back and we look, this was 0 to 2 pi. We got a lot more answers, we're not going to change the interval that we're looking. We're still going to focus on 0 to 2 pi. It's the idea that we change the period of that function. When we change that period of the function, we're changing how many times it touches the x-axis. Steps should be the same for us for right now. So we're going to solve our trig function, and we'll just do more rotations. We're going to pretend for a second that doesn't say cosine of 3x. We're going to say twice cosine of x equals 1. Your cosine of x is your unknown, so solve each side. So we cosine of x equals 1/2. Now I'm going to put that 3 back, so we know that we need to do 3 rotations. So we're talking about 1/2. It's positive 1/2, so all students take calculus, which we should be over here for positive cosine. 1/2, this is your base, this is your short base, it'd be this guy right here. So that should be pi over 3, 60 degrees. And your other 60-degree reference angle, and this would be in the 4th quadrant, is 5 pi over 3. That's just if we went around the unit circle 1 time. So now we need to go around the unit circle a 2nd time. So my second one, so this would be pi over 3, and we're going to go around a 2nd time, so plus pi over 2. Now you need to have common denominators. So we're going to multiply by 3 over 3, so that becomes 6 pi over 3. So my next answer is really 7 pi over 3. Sorry, I have a cold. And then just to save us a step, you have 6 pi over 3 that we're adding. That's to take into account the next rotation. So that would be 11 pi over 3. So that's if we went around a second time. Now we have to go around a third time. So we would have 7 pi over 3 plus 2 pi. Common denominators again, so multiply by 3 over 3, so that would be 13 pi over 3. 11 pi over 3 plus 6 pi over 3 will give me 17 pi over 3. So those are all of my answers based on all of those rotations. So it's the second step. Went around 3 separate times. Now we need to take all of these answers and multiply by the reciprocal of b. So when we multiply by the reciprocal of b, my b is 3, so multiply by 1/3. So this is really going to be pi over 9. And 5 pi over 9. 7 pi over 9. 11 pi over 9. And let's do 13 pi over 9. And 17 pi over 9. So those are my 4 answers. We hop up and we look at that picture. I'm sorry, my 6 answers. 1, 2, 3, 4, 5, 6. Those are my 6 answers. They're all falling within that 0 to 2 pi area, and we got that by multiplying by the coefficient. Next one, this one isn't too terrible, so for a second we will ignore that 4, and we're talking about where is sine equal to -1/2. So similar to the problem we just did, sine is going to be the height of your triangle. So if it's a negative height, it's going to be in the 3rd and the 4th quadrant. -1/2, so like I said, that's your height, so that's going to be the shorter height kind of hanging out. You should be thinking 30-degree reference triangle. So that would be, let's see here, 7 pi over 6, and over on the other side would be 11 pi over 6. Now this one, we get to do 4 rotations, and each time we're going to add 2 pi. Okay, so I'm going to go ahead, and since we're going to do adding 2 pi quite a few times, I'm going to take care of some stuff for us over here. So it's going to be the same as 12 pi over 6 that we're adding to each of these. So let's clean this up. So 12 pi over 6 is what we're going to add each time. So this is first rotation. Second rotation would be 7 pi over 6 plus 12 pi over 6. So now we're on our 3rd rotation. And we'll do our 4th rotation. So there we have, it looks like we have a total of 8 answers. 7, 8. Looks like we have 8 hanging out on our graph too. Okay, so now the last thing we're going to do is multiply all of them by the reciprocal of your b. Your reciprocal of your b is going to be 1/4. So this is going to turn into 7 pi over 24, so that's one answer. And 11 pi over 24. 19 pi over 24. 23 pi over 24. 31 pi over 24. 35 pi over 24. And 43 pi over 24. And 47 pi over 24. Goodness gracious. Nice little answers. And last one shouldn't be too bad. I'll go. This is just 2 rotations after all that work. We're going to just pretend for a second we don't have that 2. So divide each side by 4. Tangent of x equals -1 is what we're going to focus on. Bring that 2 back. So we're thinking about where is tangent equal to -1. All students take calculus. So we're going to be focusing on the second and the fourth quadrant. 1 as your tangent ratio is going to be a 45-degree reference angle. So that's going to happen at 3 pi over 4 and then 7 pi over 4. We're just going to have to do 1 additional rotation to get our answers. So let's see here. So we're going to do 2 pi, but we need to make it so it has a common denominator. So that's 8 pi over 4. So this is going to be 11 pi over 4 and 15 pi over 4. And last thing we need to do is come in and multiply each of these by the reciprocal. So by 1/2, so 3 pi over 8, 7 pi over 8, 15 pi over 8, and 11 pi over 8. Those would be our final answers. Looking at the picture, 1, 2, 3, 4. It looks like they line up pretty nicely.